The idea of context, context graphs, context engineering, context architecture has become an obsession in the first few months of 2026. I have written about it quite a bit. Coincidentally, last week I did another podcast with Jessica Talisman on the idea of ontologies. But this time I'm really excited to have Ananth on this podcast for two reasons. First of all, Ananth is a practitioner. He actually builds stuff. He's a hardcore data engineer. So we want to get to the practical aspects of context. Secondly, by another coincidence, he and I came up with this term called ECL, which stands for extract, contextualize, link, totally independently at almost the same time as an idea that this may be a better replacement or an architecture for well-known ETL, ELT paradigms. So today we are going to look into context in general, ECL in particular, and we're going to focus on the practical aspects. Now, why I'm so bent on practical aspects is because one of the things that I've been quite vocal about is that when data mesh came into existence, we were very excited about data mesh. What could go wrong? Domain users should own the data. They should extract and build data products and then make them self-service and then have federated governance. Great ideas, no argument. But one thing that we lacked was there was no know-how of how to build it, and we were told, "Don't wait, it'll come in time," and it never really did. And the whole space bifurcated into everyone sort of putting the label of data mesh on anything and everything that they were building. And we still see it happen, by the way, because there was no understanding of what steps do you take to build out a data mesh. So if context graphs are going to become the way forward, then we don't want to be in that space. So for that, Ananth, welcome to this episode.
Thank you so much, Sanjeev. Thanks for having me. Excited to be here.
So people know you quite well because you publish a very popular newsletter called Data Engineering Weekly. But for those who don't know you, can you please give an introduction about yourself?
Yeah, so I'm the author of Data Engineering Weekly, just like my hobby things to do that. For to pay my bill, I work for companies. Right now I'm working for a company called Zera Global. They are a leader in the marketing, their marketing platform and ad space and other ecosystems around that. Like recently we bought a company called Marigold on venturing into the loyalty space also. So there's quite a bit of data integrations and data ecosystem because marketing, ads, loyalty, everything is driven by data. So something that the domain that I'm kind of very excited about and very passionate about this domain emerging. And a lot of things, the theories and a lot of things that I'm writing is actually a reflection of what is the real problem that I'm facing every day. In terms of like, oh, we acquired this company. How do we migrate this data? How do we interconnect this data? And what is the challenges that we are facing in this? So, greatly helping me to kind of streamlining my thoughts on the data space, which I'm really passionate about it. Before that, I used to work for Zendesk and before that Slack. So quite passionate about this industry for a long time.
That is great. So let's get started. So Ananth, we have spent literally decades perfecting this whole idea of ETL or ELT. Now we are saying in the world of AI agents that may not be enough. And so why do you think that is the case? And to expand or crash the space of even like data modeling, do you think things like data modeling, creating normalized star schemas actually hurt LLM's ability to reason?
Um, if we think through this whole data warehouse as it is right, like it's a lot, it's kind of a replication of the physical world that what we kind of
Yeah.
designed so far. Like the warehouse name itself is kind of derived from like, you have some whole bunch of tables and inventories and operatings, model that you go to a giant warehouse, like the rack of things that exist in your place, and each and every item is your table, and then you go and then there is some kind of an inventory management system. You go and find what is an inventory is there and then try to go and access that one. So if you see the catalogs and those data modeling techniques, how do you organize these items together so that the discoverability of information are much seamless? And those techniques like data modeling are great concepts, but the fundamental thing that what we did it for that is we wanted to organize the information. We wanted to find the information for the humans,
Yeah.
right? That's a critical notion of how this physical world moved to a digital representation, and how human interacting with the physical world versus a digital world interaction here. So a lot of things are, and we continue to structurally design the system towards like assuming that the ETL process is around like, we extract, transfer, and load to somewhere. It's kind of a supply chain management, the kind of a manufacturing factory for that. And the humans involved in each and every steps to do that everything. It's like, manually wavering everything on top
Hmm.
of it. But what is the, I mean, the context is also not kind of a new, right? Like, look, we try to like data catalogs claims to be there, the catalogs and all the things. But what is really changed in last 2 years with the growth of this foundational models is that we have a real capabilities from a machine that we can transform the warehouse operation to a robotic operations.
Hmm.
So now the same data warehouse concept, what we really need to rethink from that is like, okay, we designed this whole modeling techniques and then data catalogs, assuming that humans going to operate as an workers to, extract the value out of it. Now, what if the whole warehouse will be operated by a robot? And what would be the whole technical design and architecture going to be look like? I think that's why the fundamental shift I feel from an ETL to ECL, whether we are going, we've seen the growth and we've seen the machine generating like almost 6% of GitHub commits are now generated by cloud. So that's going to be the norm as we move forward. And That's why there's a time to rethink what is the ETL
Yeah.
bring to the table, why we should move towards the contextualized engineering, because we are not humans not going to hold all the context. How do you transfer the context to robots or machines that can efficiently manufacture the data and bring more meaning out of it, essentially?
So we've talked, both of us have mentioned ECL. So let's break it down. What so the three terms: extract, contextualize, linking. Can you go through each one and tell us what are we extracting? What is the data source? What do we mean by contextualize and how do we do it? And then what's linking?
So before ECL, we need to kind of understand what is the ETL model that's going to be that. And we do an extract, transfer, and unload.
Yeah.
Uh, the extraction and transfer and load, the whole process essentially a contextless process. If you take a medallion architecture to all the way to the gold table, by the time we go to the gold table, the data that the context behind the business that we capture from the raw layer is completely lost or translated or buried into kind of a SQL in like SQL layer. Like somebody, like we assume that some XYZ person knows about that particular SQL knowledge, and then and that's how the context kind of transferred over the period of a time.
Yeah, actually, it's an interesting point that you bring up because when Hadoop first came into this picture, and then data lakes, even with Lakehouse, it surprised me because I came from the relational world where I spent a lot of time building third normal form ERD diagrams, where we put a lot of relationships, and then you literally threw all that away, extracted, changed data into Parquet files, and then you went through the whole exercise of adding context on top, which
Correct.
is crazy.
I think I feel like we did it a good reason though.
Yeah.
Like I think there's
Yeah.
like we try to do that and then we create another problem. That's how it works, right? Like for example, before the Hadoop era,
Yeah.
there used to be like an architecture team or something. Even a table. The data warehouse team's biggest dream was like how do we do the table change within a day, not a month. right?
Yeah,
One adding a new column within a day versus a month was the biggest challenge for many companies in that era. And the Hadoop comes in and say like, hey, I'm giving you sheer machine power and commodity hardware.
correct.
Just put everything and crunch it. Don't worry about any modeling anything because I have sheer machine power volume there. And that's how companies started to
Hmm.
believe in and put the data into this one, and soon they realized that that comes to the cost. I mean, it's a ripple effort. Essentially, once the machine power comes in, is a typical paradox, right? The machine power comes in, more data started to flow in, and the cost higher up.
Hmm.
And then people started, oh, the cost is higher up now. Okay, we need to roll back to this whole modeling technique again to revert it back to my structure the information again. That one. I feel like we are in the same phase right now that we got into this sheer machine, the intelligence coming into the picture here, and then we there will be a rush to say that okay, I'm going to point to my data and then try to figure a machine to figure it out everything, or this intelligence layers to figure it out everything, and then we can again will scale back and say like okay, we need to provide more context so that it can functioning properly, essentially. So that is a that's like we'll take a
Yeah,
leap forward and step back and then go back.
yeah.
Uh, so there's a saying that we always say like in data infrastructure, there's always something to migrate. So there.
So let's go through ECL, but let's take an example.
Mhm.
So maybe marketing. So how would you explain ECL architecture for somebody who's building campaigns or doing marketing stuff?
Yeah, so let's take a simple example of a campaign. Like let's say um, the e-commerce company wanted to run some marketing campaign
Hmm.
to increase their existing customer base. So like bringing more consumer
Yeah,
sale call back.
lead generation. Yeah,
Lead generation or something like that.
yeah.
Then they decided like, okay, I'm going to run I'm going to run a campaign. So I'm going to create a segmentation, say that whoever visited my site like last 7 days, like at least 4 times, and go to my shopping cart like 3 times, so high signal customers. So I'm going to target that one. And we so that business requirement comes in to this your data team, like hey, I wanted to build this segmentation there. And the what is getting transferred from that business layer to the data team is like, hey, I wanted to find um, the visit people visited last 5 days and then visited this XYZ page. So there is a first context lost because we don't like the data team or any data team don't know like why they decided me, like why five, why not four, why not three, right? Why they decided on the number five, and it's this context exists in someone's brain,
Hmm.
someone's mind. So then it comes to this, okay, the data layer running and crunching the business, crunching the raw layer, and then you typically go through your medallion layer and you build it as this beautiful table that says like, oh, these are the user visited in last 7 days. By the time you see the goal layer, you have a data that has like, this is a table user underscore visited, and that has user ID and then whoever visited, whatever the threshold that we mentioned that one. That table standalone or the data standalone has no value or the context out of it.
Hmm.
When you expose that to a machine or agents to do access the information there, it knows there is a table, there is person that rules there. There's no context around why the decision been made and what are the transformation happen in the middle and what is the context behind each and every transformation, and you just end up building an artifact which there's no context around that one. So ECL in this case is like it's the context on the ETL layer exists
Hmm.
in some people's mind. From a business perspective, someone decided that he wanted to run a campaign on this, and some of the ETL engineers on some transformation layer, they have some context additional. It's all encoded in human. That's how human operated a warehouse before. ECL essentially say that how do we capture and write it down this contextualization context that human hold into the commonly readable interchangeable format.
Hmm.
So how do we extract when we say that the rule is designed, there is a segmentation rule, how do we extract that information back to the flow. So all the way to your transformation and go layer that essentially has that context. They said, we wanted to run this segment XYZ date on this stuff, and these are the transformation we done it in the middle, and this is the end artifact we do that, and each and every column, what is the meaning behind that one. So that is the transformation thinking on like moving from an ETL to ECL perspective.
So if I'm understand this right, so in this example, I've got my actual data, what happened. That is in web logs, who visited, it's in CRM, who some of the users could be in the CRM. It could be in HubSpot, but
Correct.
campaign
Yeah.
and some.
Yeah. Yeah.
So that's a what. But why things happen could be in some decisioning that was done for some
Yeah.
transformation of data. So if we can extract the what and the why and then link it together, then and we sort of store that in instead of a table like an ETL, we would create a table because we were doing SQL or BI reports and dashboards, but now
Yeah.
we are not. We are giving it to an LLM. So if I
Yeah.
can extract this context from the what and the why into,
Yeah.
let's say, a markdown file or something like that,
Yeah.
then the model can pick it up
Yeah.
and I can talk to it, ask questions, and it has a context on top of the actual data. Is that
Correct.
roughly
Exactly.
okay?
Yeah, that's roughly is it, right? Like, and that and the context, the additional context that we're adding to the agents, that essentially agents can
Yeah.
correlate with like all the other decision been made,
Yes.
and then it can much more. Your business will have much more power to simulate like what will happen and what should I do, and it can like you're amplifying your capability of a business to tenfold. What
Right.
otherwise we need to hire more intelligent people into this one, more data teams to into this one to kind of hoping that to this to
Yeah.
happen here.
Thanks for that clarification because I was saying you can talk to the data, but this is not just for humans. This is mainly for agents. So for
Yes.
in a multi-agent environment, one agent does a particular task, another does something else, and so they're chained together. So they now have more information on how to go about. So
Yeah, totally. I mean, we see the trend rapidly in that direction, right? Like even like yesterday, I read about like 6% of all the GitHub commit in the public repositories actually generated by cloud code.
hmm,
And then we also kind of thinking like there's a lot of articles floating around why this cloud moment of code generation not coming to data is actually this missing context,
hmm,
like misses context because data is business, whereas code is like there's a difference between an application engineering and the data engineering. Data engineering is like you're encoding the business. Application engineering, you're encoding business rule. It's easy to infer the business rule
hmm.
from the code, hard to, because it's all in some people's isolated tribal knowledge across the institution. So that's why this momentum is pretty slow. But again, we know the capabilities.
Yeah.
Yeah. So
So that's such an interesting point. I didn't think about this, but if history tells us that the data industry is sometimes many years behind the software industry.
yeah,
Software industry in 2000 came up with Agile and CI/CD, and we had no concept. And then it took us a long time to borrow from DevOps and create something called data ops. That only happened in the last few years. Same thing with observability to now data observability. So what you're saying is that now basically the data team needs uh, to understand that machines are going to be doing more and more of our work, just like Cloud Code is doing 6% of GitHub commits. So we need to actually accelerate and get there faster.
Yeah, exactly. I mean, even for the DevOps side, like, I mean, the likes of Snowflake and the likes of the ability for spinning off a virtual warehouse is a great help to build those whole CI/CD moment and all those things. So
Right.
what happened, as you rightly mentioned, like what happened in this application layer is going to replicate slowly into your data ecosystem.
Hmm.
So the greater that we go forward and then prepare for it, that we have a better chance of succeeding against the competitors there.
One of the things that I really liked in the white paper you published on this concept of ECL was this idea about early binding and late binding. And so the thing, so if I let me put it forward to you. So what I understood was that when you do extract, there are two types of data. Data that you control, it's within your own organization, you kind of
Yeah,
understand, and data that's coming from outside that can change without your control. Like
correct.
it could be coming from a SaaS tool that
Yeah,
can change
correct.
the schema.
Yeah.
If you own the data, then you know some of the context, but you don't have the idea about the context from external systems. So explain what do you mean by early binding and late binding?
Yeah, so early binding essentially, let's say you're running an e-commerce company and you want to track your behavioral activity of a user,
Hmm,
and obviously you will do some event tracking and other things, and you already have an operational system that contains your purchase events and everything. In a traditional ETL world, what we do that is um, you either define a schema, which is like a protobuf, or like many cases, like I've seen at least 98% of the cases, there's no schema associated with it, or you just emit some JSON data randomly and then put that into these cases. And an operational data store also, you just take it on a CDC pipeline or anything. The moment the data comes to the data warehouse, it lost the meaning and the context around like why this.
hmm,
An example is like, let's say, cust underscore status. And what does a cust underscore status mean? Um, is that an active customer or a kind of a status, or is it a subscription status? We don't know that. And operational store might store as a cust underscore status. The human and the data engineers know that because they are in that organization, and the knowledge can be transferred to one human to another human, but it is never going to be infer to the agents or any machines to trying to infer that one. When I say early binding is that the ecosystem that you are extracting, that's the first layer. Right now, the way that we are extracting systems like Fivetran or any CC pipeline that we are doing, or even ingestion framework, don't carry any context to the ecosystem. There's no semantic meaning that we are carrying that one.
hmm.
That semantic meaning better understood by the team who are operating in that operational store, or the feature team that going to instrument your data. So trying to capture the semantic meaning out of it when you at the time of the extraction itself. That will save you lot of
Hmm.
uh, other inference that you wanted to do down the line. If you can solve it in a simple process or a simple tool to kind of capture that, that can go longer way, right? It's complex problem, simple solution is an early binding type. And in fact, like if you see the data contract specification and the concept,
Hmm.
essentially trying to approach that, but it was the conversation never went to more deep technical, and it was very adhere to the schema and then the quality of the data
Yeah, like
perspective.
YAML files and
YAML,
stuff like
yeah,
that. We never thought of contract in the
yeah,
context of
sim-
context, contracts
context.
and context. Yeah.
Yeah, yeah. And then if you see that Snowflake recently released an OSS specific open semantic interchange
Yep. OSI.
spec. So that they are thinking in terms of the
Hmm.
semantic meaning to how to capture that. So it's still on a YAML. I strongly believe that extraction layers should have integrated this semantic extraction also as part of the extraction process, not a
Hmm.
separate standalone process essentially. Anything that goes standalone, I don't think it'll going to work out. So that's what I kind of mentioned about early binding, that extraction logic, not just moving the data, move the semantic context
Move
around
the,
that.
I see. So that's early binding. So you extract the data, and in case of unstructured data, PDF, you extract the entities, and
Yeah.
then as you're doing that, you create the semantic layer.
Yes.
Okay.
Yeah.
And late
So
binding?
So late bending is where like the reality hits, right? Like I mean, even though we kind of trying to reach those early binding to a control data source, the nature of the real enterprise right now in two cases. So either that I'm fully on ETL, but I don't have any context around that. Like a lot of humans have this contract. So you don't really bind when the time of the data comes in. Yeah, but you are trying to infer the semantics meaning based on your human in the loop labeling
Hmm.
process or some kind
Hmm.
of a verifiable reinforcement learning environment. You're
Hmm.
trying to infer that meaning out
Hmm.
of it using AI agent. That's what I mentioned about in the nautical. There's a contextualizing pipeline that you will be running to build a
Hmm.
context store, because the reality is that we are not done that, and that's going to be the reality for data team forever, because I don't think any company will start and say like, I'm going to build a contextual data warehouse before validating my business, right?
Yeah.
The data engineering will always remain afterthought, because once the business grows, any business will start with the intuitive way of learning from a founder perspective. Then it will slowly move to a systematic approach of running the business to a more data driven. So the late binding essentially comes to saying like a contextual pipeline, look into your schema, profile your data, trying to use AI's global like LLM's knowledge about like the general understanding of it, bring validate that assumption with either human in the loop like RLHF or some kind of a LLM as a judge model where you enrich that knowledge and put it back. That's essentially I mentioned about like late binding versus early binding here.
Got it. So now, so we with this early binding, late binding, one of the two options or some combination, we've created the context layer. So now let's move to linking. What do we mean by linking? Is it making the context available through standards like Model Context Protocol, MCP, or how do you see linking?
Um, MCP, so okay, linking is another. MCP is kind of morely standardize like how we going to access the data. It's a
Yeah,
pretty good protocol that actually say that hey, you don't need to move the data. How you have an API thing like that. I
yeah,
have a protocol compatibility. Keep
mhm,
as it is. Give the ability for the agent to access that one. Make it standardized and access out the one.
yeah,
And the context graph essentially the graphs essentially representing that, like how
link.
those entities are linked, connected to each
Hmm.
other in a
Got
typical
it.
graph perspective. In my opinion, like I don't think both of them solving this fundamental semantic
Hmm.
linking problem, right? The semantic linking, in my opinion, is that there is a two entities are there, like users and the events. There is a behavioral relationship with that one, right? User um, clicked a purchase or did a purchase or user visited a page. So that is a semantic relationship between a user and its activity belongs to that one.
Hmm.
So in my opinion, linking is that the two entity is that correctly linked from a business perspective, and is that validated and accurately representing what is the model, what it represents, right? So that's what I was kind of meaning about linking in this case, whether we are representing as a graph model or you
Hmm.
just write it out on a markout,
Markdown
write
file.
a markdown file,
Yeah,
like say that
yeah,
user A purchased XYZ, and then
yeah.
this activity that you're writing, get LLM able to understand that one. That is mostly an implementation part of it.
I see. Okay. So the linking could be a context graph. It could just be a text file, like a markdown file, which could be
Yeah.
useful even like, as we get into more of the skills, like Claude skills, they can read the markdown file and then send the outcome to the next agent. So that's a linking part.
Yeah.
So I want to change tracks here a bit because we've talked about the building blocks of ECL. What is the role of a data engineer in this?
Um, yeah, so the North Star that what we are trying to do is like this whole linking and extracting those contexts has to move more toward like an inference time, right? Like agents understand all the context, and agent understand all the linking, and agents
Right.
say that hey, this is your business, new business need comes in, a new requirement comes in, and building new data assets and building new
Mhm.
insight, that one, right? But with like if it's a maturity model, if an organization doesn't adopt any early binding or late binding, because the data warehouse is not a static nature, like it's
Hmm.
fast moving. Business is not static. Business is going to move. You're going to acquire new companies, or you're going to move forward with the different things. So I feel like data engineering largely dealing with this context architecture side of it.
So context
Um,
architects.
yes. So
Okay.
your ultimate goal is to kind of build more context, build more, streamlining those whole process. Like I say, just because you have a powerful agent, you cannot just expose to a raw layer data.
Yeah.
So if you expose to a raw layer data, it leads to a hallucination. And also, we know from an industry things like too much context is also not a right thing to solve a problem, because the more knowledge, the more context that we are providing to an agent, it has to
Hmm.
compress that one. At least for state right now, the foundation model might increase the capabilities in next 2 years. May not be the case. Like you can give the entire context behind it and then trying to build something. But the
Yeah.
question essentially, like when I say context architecture, is like if you are going to build new insights to run
Yeah.
a business or trying to calculate an ARR, what is the right level of context that we are giving? Are we
Mm.
to the agent? Is agent does what it's supposed to does that?
Yeah.
I think the engineering around that is what the data engineering is all about, I feel.
So context architecture, I have to say one thing that scares me. Actually, there are a bunch of things. There's governance. You said too much context. So let's come to governance in a second. But I want to tackle this context architecture because the whole lakehouse is new. The new architectures coming out now. Database is pushing lake based quite a bit. Organizations already have ETL, reverse ETL, chain data capture. Are we going to rip these things out? Because my concern is that what is a context store? Uh, is would it become yet another silo? And if not, like how does the context silo exist in an organization? Is it S3 with Parquet and Iceberg, or is it a graph database, a vector store? Can I use my MongoDB? So these are, I've thrown a whole lot of things, but
Yeah.
the whole context architecture, is this becoming a silo?
Um, it should not be. I mean, the silo in the sense like there is a two part of it, right? One is like uh, before the step back, right? When I say context, there is a two major object associated with that one. The first is that the context object that we are talking about, right? What is the semantic meaning of the business? What is
Yeah,
the other, and we want that agent to build more and more new insights. So when agents build a new insight, it also makes some decisions, right?
yeah,
Like, so we call it as a decision object. So there's a context object, and then agent runs on the context object and build a decisions, right? Like I mean, that's
yeah. Or
essentially like
decision traces like foundation
decision
kept trace.
tracers. Yeah,
Yeah,
yeah, decision tracers or decision
yeah,
objects in this case, right?
yeah,
So both are interconnected to each other. So because we also need to understand like how agents are thinking over the time, is that thinking is aligned with what the business is kind of moving towards that one,
yeah.
and the existing context behind the thing. Now, in terms of the storage and accessibility and all those things, um, the physical storage is it depends upon a different company, like different companies and different architecture,
Hmm.
what they wanted to do that one, right? If they wanted to store in Postgres or the that's one of the reasons like kind of very excited about the open table format. The Parquet actually kind of moving fast, and we got like LansDB, like supporting multimedia,
Hmm.
multi models and other things are emerging. So my belief is that we will have a long-term storage, which is co-located to the lakehouse
Hmm.
model that also contain the context along with that one. The open table format already kind of enriching and enhancing more towards
Hmm.
that, like supporting more tier data types and more model types around that one. So I would expect like let's extend that and co-locate that one. But if some reason wanted to um, delocate that also, like storing in a Postgres or a MongoDB, as long as when the agent is accessing, you're able to give the both the context and the data together to the
Hmm.
accessing information.
Hmm.
Whether you are resolving at the read time or you are materializing together, it's up to the different databases and the different the distributed system nature of it. But as long as you're able to provide a unified view to the agents to access that one, um, there will be some case of a specialized softwares, like for example, Neon kind of a thing, which essentially holds like when an agent wanted to run, it typically in a multi-tenant environment, you wanted to isolate the context and you wanted to provide a strong multi-tenancy and then security and
Yeah.
other aspect of it, right? So you may want to spin off some temporary ecosystem that copied over the context from a short-term memory to um, like a
Long
long-term
term.
storage to short-term storage,
Hmm.
and then store the context and the decision graph there and make the agents to run, and then more of an informal way of handling the ecosystem also there. So I see, because you have somehow you have to balance like the speed of execution and then the correctness part of it. So I
Yeah.
see that architecture is kind of emerging, that you have a long-term context and you will have a just-in-time context, essentially like just enough context to a short-term memory kind of a model. There will be I
Hmm.
feel like there will be a specialized engines might come that agents operate on that, rather than the full memory that you will have or full context that you have about your entire data ecosystem.
Yeah. So this is a fascinating topic because I feel like we're opening a brand new chapter in data engineering. A new because in the past we had like in the ETL, the data flowed from left to right. The data originated in some operation system and then it got transformed, cleansed, merged, integrated, whatever, and then it was consumed. But now AI is going to agents are going to create their own data. So the data is not only coming from the left, it's getting created. And so what you're saying is that we have long-term memory to store all this intermediate data, decision traces, and all of that information. But then there's a short-term memory where it may pull from long-term memory because while the agents are communicating, they need to know the context, and so that may be ephemeral, short-term memory, so and for that we may actually use some caching technology, you know.
Yeah,
So, and I'm just
yeah,
reading, so when I think cache, I think Redis. But I just reading Postgres 18 now has this uh, single millisecond cache technology. So all these technologies, of course, then Neon already is there.
yeah,
So it's
yeah.
very interesting what's going on.
Yeah, totally. And even the agentic architecture also moving into a similar way, right? Like, I mean,
Yeah.
even the cloud code recently has a Steam agents, where
Yeah.
and we also kind of iterating into a similar architecture style. Like, it will be a one primary agent and then like a mini sub agent. Each sub agent will have its own context. So
Yeah.
you divide and conquer kind of a model that proven to be working really well, because too much context to one particular agents or transferring the
Yeah.
agent to a sub agent causing a lot of issues.
Correct.
So
Yeah.
I think so. Yeah, that's how the model. That's why I was kind of mentioning like why this access is the key part rather than the physical storage. When sub agents, you will be distile or you will be extracting a just enough context to each and every sub agents,
Correct.
and then sub agents
Yeah.
wanted to access the data. So that interface is where the the challenge, and then that's where you need to
Yeah.
solve this problem with that.
Because we've seen that too much context can confuse agents. So
Yeah.
it has to be just enough. So this architecture is still being conceived and developed. So we don't have all the answers. But the big question that comes up is all the non-functional requirements like availability, performance, scalability, security, and governance. So how do you unfettered access to context can cause all kinds of problems. So has that been something that has bubbled up? Like how do you maintain security and governance, privacy, compliance of context?
Yeah, yeah, totally. So I think in terms of the privacy, security, and contact, like the same rule that we are applying for like what like if I'm a data engineer and then
Hmm.
what is the capabilities that I have, but what I
Hmm.
can access, that should apply to the same to an agent, right? Even the moment you started like agent is a human role, and the similar security policies, everything is kind of applied.
Yeah.
And we try to approach the same way to the services, right? Like service, like if you're developing a services, and then that's how AWS is trying to do with the IAM role and all those things, like services assigned to an IAM role and then trying to assign that one. But the agent is little more and more tricky than when the typical services and human is, because a service can operate multiple sub-agents. So you can still hold one IAM role, but you can run like a multiple sub-agents
Hmm.
or multiple agents, and each and every agents can have their own should have their own visibility and then access permission model. They should inherit that one.
Yeah.
So I think um, the the governance part, what at least like the current design that I'm trying to solve is like agents getting assigned whenever accessing certain resources, getting a just enough like at that like the like more of a just in time privilege access, trying to infer and say like hey, I am this agent, I wanted to apply access this resource, give me that info. Do I have an info? Do you have an access to that one? So the MCP protocol, in a way, that's kind of really helpful. That MCP gateway essentially
Hmm.
standardizing that access control and access control there. So I would expect, so MCP protocol still kind of largely REST focused. I would expect like a similar kind of a protocol or extending an MCP protocol more to a table access level also, kind of a gateway that infer the agents just enough time. Right now, the way Cloud Code and everyone is working on like having this own sandbox environment and
Yeah.
trying to run any command, ask permission modeling things. So I don't think in a an atomic agent side of it, like you cannot ask permission every time. There's no human in the loop, but so I would expect like some kind of a gateway that will solve that. So MCP gateway is already on that path, so should be extending more than.
In the interest of keeping this podcast very practical and uh, implementation focused, what do you think listeners should do next if they were to get into ECL or the context space?
Yeah. See, one of the fundamental nature of data is inherently social in nature, right?
Hmm.
If you are trying to build, let's say that I'm going to build a semantic layer for my entire organization, or I wanted to build this ontology definition for entire organization, so I call this knowledge graph. Then, like we've seen that, like it failed all the time, right? It's not going to work out
Yeah.
anywhere. And I quoted that data is social in nature is the reason is that you don't need to start across every ecosystem. Just identify one
Hmm.
business rule,
Okay.
one business flow that you are critical to a company, or like you wanted to invest, you wanted to iterate more on that, and then from there extract those context and contextual running the contextualization, whether you want to do an early binding, is there a data in your nature, in your control or not, should we adopt early binding or should we adopt a
Yeah.
late binding. So take that one business flow, understand is it a early binding is a quick win or a late binding is a win for you, how we can bring the human in the loop labeling process into this one. Once you've done that one side, like even a one table, even it's like one small table that you do,
Hmm.
because of the social in nature, as you do two to three, the interconnection started to come in, the linking started to come in. It'll accelerate, it'll give you compound value
Hmm.
proposition as we go. So you don't need to worry about like building entire linkage as together, but you can start doing this one. Many data warehouse right now, they don't have any of this relationship already established. Like we know that user and events are connected, but there's like even if you take a Snowflake or anything, there's no like a primary key foreign key relationship. There's no like a ERD kind of a model that you can say like this is how my universe is connected together. Um, so if you want like and so one of the way practically if you wanted to approach is that like there are enough libraries like SQL Mesh, for example. You can get your history logs, like all the SQL query that you can fire from this
Hmm.
history. You can actually infer the whole ERD diagram. So once you infer the ERD diagram, essentially like because when you query that, you can just infer like what are the tables are joined together. You can
Yeah.
build a yard on that, and then identify like where all the connection goes. What is my core table here? And identify from the core table, and then start building there, and then go fan out. Then your compounding of value proportion increases a lot.
Hmm.
In a typical environment, like for example, users is like our users or profile information that represent a core dimension of it, that often is well connected across multiple tables. So if you solve one table, then you and then well connected tables first, you will accelerate your business a lot.
Got it. So take baby steps, a well-defined small problem.
Mhm.
And in fact, I was even thinking if the context, like in this case, you're saying like take a table that's well known, so you have the
Yeah.
context, so early binding. But
Yeah.
even then, come up with some evaluation scripts, like
Yes.
what's a question and answers, so you can then test whether the agent is returning the right responses. And so do a proof of concept
Right.
and then build upon it. Okay.
Yeah.
So amazing. This has been, I think, the first time I'm feeling a little bit more at ease with this concept than I have since the beginning of this year when the whole thing was unleashed upon us. So as we come to the end of the podcast, is there something we missed or something you want to add uh, from your experience that you'd like to share?
Yeah. I think one of the thing is like there is a two aspect. Like one is like if I'm a data engineer, what should I
Mhm.
really focus on right now?
Yeah.
And I think that's kind of a common question right now. Like if an agent can done every time, like what should I do? This one. I think the data engineering is much more valuable than what
Hmm.
we are thinking right now. It's like
Amazing.
we never thought of extracting context before the data. We're thinking like,
Yep.
we even joke like data engineers are moving data from one bucket to another bucket, right? So
Hmm.
this is something the profound contextualization of the data moving. It requires a fundamental rethinking of a framework and then reinventing ourselves on this scale. And the more we do context, we will able to bring in more and more data that in otherwise not able to do, or not we
Hmm.
thought like extracting value out of this data is pretty hard, and it just cost the company. Let's do some retention policy and then move it away, and other things. I would expect like more and more and data flow comes in, and more companies will be inherently will be data driven, is because people not more data driven because that complexity around the
Yep.
CTL pipeline around that one. So I would say like, there will be increased
Yeah.
number of data that we'll be handling on those things. So I'm very excited about data, and it's much more relevant
I,
than
I think the way you're ending is brilliant. Data engineers, instead of being scared as to their jobs going away, can finally bring the institutional knowledge, the business strategic imperatives into data engineering. So don't
yeah,
just be an order taker and move stuff from point A to point B,
yeah,
but try to bring that business knowledge, context, uh,
yeah,
apply, overlay it on the data that is being moved. And I would say, in if you listeners are doing a POC, a small one, put unstructured data as
yeah,
one of your data sources to do the extract part. And you
exactly,
may be using maybe your LLM or LangChain or Llama Index or whatever it is to extract the chunking, extracting the entity and
yeah,
embedding it.
yeah.
But that itself uh, will add to the value that you bring to your POC.
Exactly. A simple example is that, like, let's say, for example, I want to run the campaign. There is some business meeting happening around to kind of understand about campaign, that discussion going with the marketing team. I don't expect like marketing team come and say like give me all the context and say like this is why I decided. Like that's humanly impossible, right? Now you're building a pipeline that listen to the conversation and extracting like what is the context been discussed and putting through the pipeline. And this kind of data engineering that we always wanted to do, that we always wanted like
Hmm.
data to empower the business. We never able to do that. And there's a golden opportunity for us to kind of, move towards left more like integrate into the business perfectly for that.
Yeah, great note to end this podcast. I think the golden opportunity for data engineers is on the horizon. Now is the time to shine and deliver value. So with that, thank you so much. I really appreciate all your knowledge sharing. And as you get deeper into this, maybe in a few months we could revisit this and see how it's working. So with
Yeah,
that,
absolutely.
yeah. Thank you everyone for staying till the very end. Until next time. See you then. Bye.